Hello, my name is Anubhav Swami, and in this video, I'll talk about Remote Access VPN for Azure using Cisco ASAV and Next Generation Firewall. So first of all, I want to highlight that during COVID-19, there is a huge spike in request for work from home, and ASA and Next Generation Firewalls can act as a VPN head end, and which is going to provide you all the good and cool features of remote access VPN. You can terminate IPsec VPN or SSL VPN, and you can also use this virtual device for site-to-site VPN going back to your data center. So this is a quick overview of the architecture which I have presented a couple of months ago, and I will add a link of this video as well in description of this video. What I'm going to do here is I'm going to present a three-tier architecture: web, app, and database. And at the edge we have outside subnet, and our firewalls are in the middle of outside and web subnet. So consider these firewalls as the edge devices, and you can use Azure DNS or any other DNS of your choice, and you can ask your users to connect to a DNS name in their VPN AnyConnect profile. What it does is it is going to talk to your DNS, and your DNS will forward traffic to one of the firewalls available in Azure. So there are two options. First one is you can have same VPN pool for each firewall, and then you source net any inbound traffic to your inside interface. And the other option is you can have separate IP pools for each firewall, and you can define your UDRs in such a way that traffic will come back to the same firewall where initial packet is seen or where your VPN user is connected. So both options are available, and we recommend using a DNS solution that can track your firewalls and load balance your VPN sessions. The other thing is, if you have multiple VPCs, it becomes really difficult to have firewalls in each VPC, and so deploying firewall in each VPC is not a scalable model. So what we have here in this architecture is, if you look at this particular architecture, we have created a hub VNet, and hub VNet is connected to spoke VNets using VNet peering. And in addition to that, if you have express route, you can connect your express route to VNG in hub. Otherwise, you can also use IPsec connection between your data center and your Azure cloud as well. Now, if you look at this particular architecture, I have a hub VNet which is 10.82.00.16. In this hub, I have multiple firewalls, and these firewalls are between two load balancers. So you can call this architecture as an architecture of load balancer sandwich. You can see that I have external load balancer and internal load balancer, but these load balancers are not playing any role in VPN. These load balancers are basically used for inbound and outbound traffic. In the upcoming slides, I will talk about why these load balancers are there. If your use case is not inbound and outbound connection or traffic flow, then you can avoid these load balancers as well. So what I'm going to be doing is, another important thing that I want to showcase here is availability zone. So you can see that first firewall is in availability zone 1, then I have second firewall in availability zone 2, and then I have third firewall, just to maintain resiliency. By default, when you deploy firewalls using ARM template, availability zone is not there by default. So what you need to do is you need to go to your ARM template and add these two attributes there, so you need to define zones. So for firewall 1 you can say zone 1, for firewall 2 you can say zone 2, and for firewall 3 you can say zone 3. So this information will go to virtual machine and public IP address. So you need to modify your template and then deploy these devices. By default, these attributes are not there. So in the description of the video, I'll go ahead and add a link to ARM template as well. But remember, those templates were created like 2 years ago, so you might have to update your APIs as well. Load balancing is really important. I'll talk about load balancing traffic using DNS first, and then I will talk about Azure Traffic Manager. So now if you look at this particular architecture, I have Azure DNS. So user is going to initiate DNS request for Azure DNS. User is going to get reply, and then user makes connection directly to the firewall. So this is how you will load balance traffic. Now what happens in this particular architecture is your DNS is going to load balance traffic. It is going to maintain a record for each firewall. You can define TTL on your DNS server. Remember, if you look at this domain name server Azure DNS, it does not natively provide any kind of health check. So in the event of failure, your DNS is not going to be notified. So even if, let's say, your firewall is no longer available, but your DNS doesn't know anything about that, and DNS will still forward traffic to that particular device. So if you have any other DNS which can do a health check of these devices on, let's say, port 80.443, you can enable that functionality as well. We recommend using multiple firewalls per availability zone. For sake of simplicity of this diagram, I'm just showing one firewall per availability zone. Now these firewalls will act as your VPN devices, and when I say VPN devices, you can terminate your IPsec tunnel, you can terminate your RAVPN, it could be IPsec or SSL, but majorly this architecture is for remote access VPN users. Now there is VNet peering between VPCs or VNets, and then for data center connectivity, it could be IPsec, it could be express route, it could be any other form of connection going back to your Azure cloud. Make sure that this connection terminates into hub, so that from hub you can talk to other VNets as well. Now let's look at a couple of things here. So when you define your air records in your Azure DNS, you will map it with public IP addresses of each firewall. By default, you don't get public IP addresses on the firewall itself. What you will do is you will attach a public IP address on outside or external interface of your devices. And each firewall is going to have that public IP address, and that public IP address is going to be used in your DNS server. Again, you can use Route 53 if you need AWS Route 53 if you do want to do a health check, or you can use any other load balancer as well. So we just need a load balancer or a DNS that can track devices. Otherwise, if you're okay with using a DNS that doesn't do any kind of a health check, that is also fine, but that is not our recommended design is. Now VPN pool is really important to understand here. You can see that I have defined a separate VPN pool for each firewall. Intention of defining separate VPN pool is to have routing enabled in such a way that respective VPN pool traffic points back to the same firewall. Important thing here in Azure is if you have VNet peering, you need to make sure that all the VPN pools that you define here should be part of the CIDR range. Otherwise, that traffic will not flow through your VNet peering. So that is really important to understand and keep that in mind while creating your VPN pools. Now, I have already talked about this limitation already. I'll not focus more on this one, but you have an option of using other DNS as well in order to provide VPN load balancing. Now let's go to some intelligent load balancing mechanism. There is a native service available which is known as Azure Traffic Manager, which is ideal for this particular solution. So in Azure Traffic Manager, you have option of defining your weighted average load balancing. You can use it for load balance your VPN traffic. It can load balance traffic to multiple availability zones. And the best part is you can enable probes. So your Azure Traffic Manager is going to probe your firewalls, and if there is a failure of that device is marked as unhealthy, and going forward any new VPN connection that will land on Azure Traffic Manager is not forwarded to the dead firewall. So again, you can use multi-AZ architecture or single AZ architecture, that is up to you. That is really important to understand, because if you want to add load balancers, you should have one of the two things. Either your devices should be in availability zone, which is a separate data center connected with a high-speed link in the same region, or you can have availability set. The availability set is something that will ensure that all these firewalls are not deployed on the same piece of hardware. They're spread across multiple fault domains. So if there is a maintenance from Azure side on their hardware or software, all your VMs are not impacted. So if you want to add firewalls in the load balancer, make sure that your firewalls are in AZ or at least availability set. Now again, VPN pool is same story. If you go with this particular design, make sure that you have a VPN pool defined, and those VPN pools should be separate. So first firewall has 64.0/18, 128.0/18, and 192.0/18. I have taken bigger VPN pool because I'm assuming that we are installing at least ASA v50, because those are bigger instances of our firewalls, which can go up to 10K AnyConnect VPN endpoints. Now let's look at our route tables as well. This is a route table which is attached to one of the spoke. For sake of simplicity, I'm just showing one subnet here. It could be a 3-tier architecture, it could be any other sort of architecture in that VNet. But if you look at my route tables which are attached, I'm using a route back to my firewalls. .10 is my first firewall, .11 is second firewall, .12 is my third firewall. So I'm making sure when these workloads will reply, they will reply back to the same firewall where your VPN user is connected. Similar route table is configured here as well. So this is something that you can look at as well. So you can merge these two route tables and you can create a one route table, but that is not recommended. I would suggest you to have a separate route table per VNet. Now look at the routing on the firewall. So if you look at this route table that I have here, so I have two routes, 1083.0.0/16 that goes to 2.1, which is first IP address of inside subnet, and that is Azure network. Second route that I have is for spoke 2 VNet, which is 1084 00/16, which goes to again 1082.2.1, which is Azure network. And then I have a route going to back to data center as well. Same kind of routes are added on each firewall. Then I have IPsec terminated on ASA or FTD and going back to the data center. Now let's look at our Azure Traffic Manager configuration here. So you can see that I have a transit gateway, or you can say traffic manager, created here. Under this traffic manager, I have 3 firewalls: ASA 01, 02, and 3. All these devices are online, and these devices are Azure endpoints. So these are VMs that I have in my hub VNet. Now, next thing that you can see here is on the load balancing side, I've created a wait 1. So I'm going to be load balancing my traffic equally amongst these firewalls. Now, how I have added the wait, so I can go to configuration, endpoint configuration. In my load balancer, I can specify public IP and I can specify wait. So this is for firewall 1, same config for firewall 2, and same config for firewall 3 as well. So I'm making sure that first of all, I'm probing these addresses. I'm defining my public addresses here so that my ATM, Azure Traffic Manager, can reach these devices. Okay. Now, other thing is probing. Probing is really important. What I'm doing here in this probing configuration is I've defined a TTL of 60 seconds. I have used TCP protocol, and I'm probing my firewalls on port 443. Since I have my AnyConnect VPN running and it uses port 443, so I'm just probing my traffic port instead of port 22 or port 80. I'm just using my traffic port for probing. So you can see here, if you look at my transit gateway or traffic manager matrix, you can see that I have these firewalls available, healthy, and they are up. So any traffic that will land on DNS name of the Azure Traffic Manager, it is going to be forwarded to all the firewalls defined in Azure ATM endpoints. Now, VNet peering, you can see that I have VNet peering as well. This VNet peering is defined in Hub VNet. So I have 2 peers connected, one going to spoke 1, the other going to spoke 2. So this is pretty simple. You need to go to your VNet and you need to click on peering, and then you can create a peering. You just need to define your source and destination and you are done. On my spoke 1 VPC, I have connection back to hub. Similarly, on spoke 2, I have connection going to hub as well. So nothing very tricky. You just need to define point-to-point connection, and these connections are known as VNet peering. So you can definitely go ahead and create it. User-defined routes. I just wanted to show you my route tables as well. Very important, because without proper routes, your architecture will not work. So this is my hub inside UDR, and if you look at this particular UDR, I have a route for VPN pool going to firewalls, and I have default route for my internet connectivity, and that points to 1082.2.100. That is virtual IP address of my internal load balancer, and this is for outbound connectivity. For example, if I have an application server that would like to download any update or patches, that server is going to send traffic to internal load balancer, and on the way out, internal load balancer is going to load balance traffic, and this load balancer is also capable of load balancing traffic across availability zones. So if you have 3 firewalls, it is going to be load balanced. Now this UDR is attached to inside subnet. Same kind of UDR is there on spoke 1 as well, but routes are a little bit different. I have another route which is for 1084.00/16, that is my spoke 2. So in spoke 1 UDR, I have route for spoke 2 network as well, and that also points to internal load balancer, which is there in the data center. So that traffic, east-west traffic between two VNets will also cross firewall. So if there is a requirement that you want to filter traffic or inspect traffic between two VPCs, you can take that traffic down to your hub, and in your hub you have internal load balancer. That load balancer is going to take care of that inspection and that load balancing across multiple firewalls. Your traffic is inspected on the firewall and then it will return back via same interface. There is no requirement for source NAT when traffic is east-west, because UDRs will take care of your return route. And your ILB standard is a load balancer that can keep session information. So any session which any traffic or flow that is received on the load balancer, it is going to forward that flow back to the same firewall where initial packet was processed. Again, in the spoke 1 inside UDR, I have routes for my VPN pools, and then I have default route as well for internet connectivity, and this route table is applied to spoke 1. Same route table for spoke 2 as well. VPN spoke 1 route and default route attached to spoke 2 inside subnet. Now VPN load balancing, you can see that I'm connected. I'm using Traffic Manager domain name here, DNS name here for in my AnyConnect client, and I'm connected to Firewall 1 right now. I can ping my internal resources. Now I'm connected to Firewall 2 and I can ping my internal resources. I'm connected to Firewall 3 now, and I'm still able to access my resources. So if you have large number of VPN users, you can terminate that traffic on multiple firewalls and split your VPN. And we do understand during COVID-19 there is a requirement of remote work from home, and you have a lot of users working from home, and you cannot rely on HA model, which is restricted to only 2 firewalls, whereas this model can scale up to multiple firewalls. For non-VPN traffic, if there is a non-VPN traffic that you want to use, this is a outbound traffic flow. So you can see that this server initiates a connection. There is a UDR that will force traffic to internal load balancer. Internal load balancer will then send it to one of the firewalls available in the backend pool, and on the way out, traffic is source NATed to external interface of the firewall. Pretty simple. So it's similar to load balancer sandwich model that we showed earlier. Now let's look at this one here. Another example of traffic flow. If you are in your spoke 1 VNet and you want to reach out to spoke 2, that traffic will still go to internal load balancer because you have that routing defined in the route table. Traffic will land on internal load balancer. Internal load balancer is going to forward it to the firewall. If allowed, your traffic will go to destination VNet. Another flow is when your traffic is inbound. When your traffic is inbound, you will see that traffic will land on external load balancer. External load balancer is going to forward it to firewall in the backend pool. And what you will do is you will source translate your traffic, send it to the destination machine. Now why we are doing the source translation is because we would like to use a mechanism by which traffic will come back to the same firewall. In order to maintain symmetry, we generally go ahead and source translate our inbound traffic. For users who are not connected to VPN, they are still protected. You have modules that you can use with ASA. On ASA, you have capability of using umbrella module and AMP for endpoint module. If you have those two modules enabled along with Duo two-factor authentication, you can still go ahead and protect your remote worker even when that remote worker is not connected to the internet. So you can create policies on your Cisco umbrella portal, or you can create policies on AMP portal, and those policies will be still applied to the user even when that user is not connected. Another important thing is split tunnel. If you want, you can send everything to your data center, which is shown here. You can send everything to your cloud environment. If you do not have split tunnel enabled, you can send everything. So even if you are trying to access anything on internet, that traffic is going to be forwarded to your data center or your cloud, and from there you can reach your internet and then you can use those services. But if you want to use split tunneling, then you can define your interesting traffic, and only interesting traffic is going to be pushed to your cloud. Apart from that, everything else to the internet is sent directly. This is done to save bandwidth and send only traffic which is required to your cloud. There is a cool feature on ASA where you can create a dynamic split tunneling and use exclude feature. For example, if you have WebEx, Salesforce, Office 365, and your users are consuming those SaaS services, and while they're working from home, this traffic is choking your bandwidth in your cloud or in your data center, you have option of excluding domains. When you exclude domains, your traffic to those domains will not go through VPN tunnel. That traffic is going to be sent directly through the internet. There is another feature which is VPN always on functionality. If you have critical data, you can always configure your VPN in such a way the moment your user is going to connect to internet, they will form VPN tunnel back to the cloud or data center, and everything is going to be tunneled through the IPsec tunnel or TLS back to the data center. Now Duo is used for two-factor authentication. As you might have seen, you can have integration with Duo. You can send a push, call, or text for second factor authentication. You can configure Cisco Umbrella for DNS layer security and IP enforcement, and you can use AMP for file and malware analysis. So these are the three pillars that you can integrate with Cisco AnyConnect VPN client, and you can protect your workloads. Exclude domain is going to work with these as well. So even with the exclude domain, you are still protected with Umbrella. So any policy that you have defined in Umbrella or Duo, that policy is going to be still applied to that remote worker, and even the endpoints, the M for endpoint will still function on that user. If you are connected to the untrusted network and you have always on VPN, so everything will go back to your cloud or data center, and from there you can apply your Umbrella policies, Duo policies, and AMP policies. If you are not connected to your data center, you are still secured because you have AMP for endpoint installed on it. You are being protected by Umbrella. Because you have those policies pushed down to your AnyConnect VPN mobility, and you have different modules which will make sure that your traffic will go to umbrella for your DNS request will go to umbrella, and your umbrella is going to define what traffic you should access and what should not be accessed. And if you get any file, if you try to download any file which is infected or a malware, AMP4 Endpoint is going to be taking actions on that particular file. For non-VPN users, you can install Duo Network Gateway as well. Duo Network Gateway can integrate with various identity providers, and which will provide you secure connectivity back to your cloud or data center resources. And this is not basically a firewall solution. You're just terminating connections on DNG, and from there you are making sure that your connection is encrypted and you can access your internal resources. Now let me show you how exactly your Cisco Secure AnyConnect mobility client would look like. So this is to show you that here I am using DNS name, and this DNS name is defined as a CNAME on one of my DNS server, and that CNAME points back to Azure Traffic Manager. So az-srwvpn.com is going back to my Azure Traffic Manager, and Azure Traffic Manager is doing the job of load balancing my traffic. And you can see that I have umbrella module active, so any policy that is defined on the umbrella module is going to be applied on my remote worker as well. Another thing is I have AMP enabler installed as well, so I have integrated my ASA with AMP as well, so I can create file policies, malware policies, and all those policies will apply to my user whether the user is connected to VPN or not. So pretty cool feature. With VPN you can integrate these modules. There are other modules as well which I'm not discussing as part of this particular video, but you will integrate a module like network visibility module, and there are several other modules available. So the intention is to show you VPN load balancing, then umbrella integration, Duo integration for dual factor authentication, and then AMP for endpoint as well. So with this I have reached the end of this video, and I hope you have enjoyed this video, and thank you for watching.